Hello to whoever is watching. I hope that you're okay during these times of struggles. I would just like to take you through my final year project and show you some of the capabilities that it has. Thank you very much for watching, and I hope you have a great day or night or whatever it may be. Thank you. My final year project is a real-time poker AI. The easiest way to think of this is that you're playing a cards game, in this case Texas Hold'em, against a robot that is leagues ahead of everyone at the table. This is what my project aims to achieve, and this is how I do it. I collect data and generate meaningful datasets on the fly through the use of RFID and speech recognition technology. I then design a decision-making function based on game theory, the strategic nature of the game, and machine learning techniques. I then incorporate and build this system into a standard poker table with one simple screen aiding a player of choice with the optimal decision to make at that given specific moment in time. So, the first step, how does the AI know what cards it has? Okay, so we have everything set up. We've got our Raspberry Pi, our RFID reader, our headset, the Ethernet cable, our RFID tagged cards where every single card has its own unique value on it, which can then be decoded into a card value onto the screen. And then we are connecting to the screen remotely using a VNC service, so you can use your computer or your phone to access this screen. So, the first step, how does the AI know what cards it has? Let's just take two random cards from this playing deck. We'll go here. Now, we can place these two cards on the reader at the same time or individually. It doesn't actually matter. So we'll place both of them on at the same time. And we have the Ace, 6, Hearts and Diamonds. And just to make sure that that is correct, we'll have a look. So that's correct. So we are now in the initialization phase. It is requesting who is first to act, and this is only done on round 1. So this is a simple answer. I have preset the names to Hero, Beta, or Charlie. Hero is sitting on the left, Beta is sitting on the top, and Charlie is sitting on the right. So I would use the speech, or the dealer would use the speech recognition technology and announce Hero. And then we move on to the next phase. After the initialization phase, the button, so the dealer button, and the small blind and the big blind get displayed on the screen accordingly. This dealer button moves 1 to the left after every single round. So we now move on to the gameplay collection phase. So the current screen is requesting what the current action is. So the action is on Hero. So the dealer, in whatever given case, would use the speech recognition technology and announce the current action as it happens. So an example of some action that could occur would be something like this. Raise. Call. Call. And then, after that action has been collected, we move to the binarization phase. So it's kind of hard to go into the binarization phase as there's no kind of graphical display for it. So this is what a standard gameplay state would look like in a dataset after binarization. The useful thing about binarization is means we can work out all of the computations and calculations
way faster than we could have if the information wasn't binarized. So here we have, for example, when someone 2-bet raises, 1 will be put in if they did, 0 if they didn't. And that's as simple as that. From this, we can then group them and get their overall tendencies in this kind of data set here. So, for example, player alpha would have 2-bet called 22% of the time for this given gameplay state. I don't know what this one is. I think this is a 100 test hand that I did. And then from this we can get kind of some really big main poker statistics like VPIP, aggression factor, folding to 3-bet, all these kind of really, really good statistics that we can draw conclusions from and evaluate other players' cards or their range of cards that they hold. And this brings us on then all these statistics and evaluation into the decision-making function.
So the decision-making function is actually quite straightforward. We've got a fold, check, call, raise scale. The more green the box is, the more you should do that action. The more red, the more you shouldn't do that action. So we've got an interesting spot here with ace-2 on the big blind, and the action has gone raise, re-raise, so 3-bet, and now it's on us with ace-2. So our classifier or our decision-making function has evaluated that we should be raising in this spot and sometimes calling, but most of the time definitely not folding. This conclusion was drawn from the internal machine learning, the 4 classifiers that are used for the fold, check, call, raise, and heavily based on the important features that were drawn from the previous gameplay state. In this case, I would not often 4-bet with ace-2 suited, but given that player Charlie has 3-bet a lot, has a very high 3-bet frequency, he could be doing this with a very weak holding, meaning that we could just win the pot right now. I will now talk about the important features and explainer part of the project, which is also a really good way to teach players while they're playing about important things to draw out of a game and things to take into account when you're making a decision, and things that my classifier or my machine learning model took into account when it was making its decision. The important features and explainer part of the project was done using an algorithm called xgboost. xgboost is an implementation of gradient boosted decision trees designed for speed and performance. I was able to use xgboost to compute the most important features present in the current gameplay state. At great speed, I was able to compute that. I would then apply my kind of own filtering method. So I would I would get the importance value for a particular feature, and then I would put that from highest to lowest, and I would take the top 5. And then I needed to explain certain types of features. So in this case, 3-bet tendency. I just have it that player X has a very 3-bet tendency. So that could be very high, high, low, very low. That's one explainer that was already predefined. And the same one for player X is playing very tight, tight, loose, very loose. And so on, so on. And that's how I defined my explainer. So I computed my important features with xgboost, and I made my own explainer to explain those important features that I had drawn using the xgboost algorithm. And then we just go on to the next round, and that is my final year project. I hope that this video was informative, even though I kept it at a relatively high level. I didn't want to go into too much detail regarding how the RFID reader worked and the Raspberry Pi and all the internals and the communication channels between the RFID reader and the really tech parts about certain parts of the project. I just kind of wanted to give a high level overview of how my project worked and give some sort of deep insight to some of the functionalities of it. And I hope that this video was relatively informative in that way. And again, I thank you for watching this video if you made it to the end. And yeah, thank you very much. I hope you have a great day.